using KVM on ARM servers. My name is Andrew McDermott. I don't know if Michael is in the audience. That's a shame because he was presenting half of these. Oh, there you are. So this slide shows that we have three Mustang boards. On the first Mustang board, we are using, it has a Jenkins master running OpenJDK 8. And I call out OpenJDK out in particular because we're trying to dog food the daily CI builds that we do of OpenJDK 8 in particular. We're using Juju to actually deploy OpenStack, and the non-compute parts of OpenStack are being deployed on LXC containers, and that's purely just for isolation, really. Also because we have a limited number of machines that we can try this on. The other two nodes are compute nodes, and we're going to show Jenkins running on those. The instances will be booted through KVM, and again, the VMs that we spin up there are actually using OpenJDK 8 in particular, not OpenJDK 7, which comes with, say, a standard Ubuntu distribution. And our goal there is really to continue dog fooding the builds of OpenJDK 8 that we do in particular. So as I mentioned, the three APM Mustang boards, and the point about Juju is that we want to do a production deployment. I mean, I have played around using DevStack, but we want to do this for real, and people in the real world are going to be using something which is not DevStack based. And the goal of the demo is to basically run a subset of the OpenJDK JTREG tests. And I say a subset because there are around about 18,000 of those, so they do take a while to run. And if the demo gods are with us, we're going to basically dynamically provision 6 VMs using the JCloud plugin, and there's going to be deployed on OpenStack on the Mustang 2 and 3 boards that we've got. It says here that the VMs will be destroyed upon test completion, but in this case they won't because we might be using them later. Okay. Let me switch to my demo. So here we have the Jenkins dashboard. You can see down the left-hand side under the build executed status that the system is quiescent. This single job that I have here, we have this matrix, which is nice to basically parallelize out. So as we mentioned, we build the server and the client compilers. Those are the C1 and C2 compilers. And in the OpenJDK tree, there are some regression tests known as JTREG, and they're split up into hotspot, langtools, and JDK, which gives us this nice matrix that we can actually scale out and do testing. So ordinarily, if you run this sequentially, it takes many hours, but if we have some additional machines, then we can split this up and do the CI testing and integration a lot quicker. So if you bear with me, we're going to basically, I'm going to start this job now. And we have no nodes provisioned right now, so JClouds. So we can see that we have the build queue is 6, it's stacked. It's going to then go and start some instances for us. So while that's happening, we can go into the OpenStack dashboard, and we can, Right, this is what I wanted to show. So this is the setup of OpenStack we have has got 5 Mustangs registered with it as compute nodes. So we have a lot of CPU here and a lot of disk. And if we go back to the project view and the instances, we should begin to see that some of these images are now being spawned by JClouds, and then the test will start running on those. So the image name is called OpenJDK JTREG image, and the reason for that is it's just a modified trusty server image. The only additional things I put on there are the build dependencies for OpenJDK so that we don't have to watch those download. So if we go back to this side of the demo, yeah, we're still waiting. So, I mean, this view is quite useful because you can see that on the Mustang board, we're running Jenkins master on AArch64. And as a point, I've been using this internally for 6 months now. And the daily CI and build that we do to produce the OpenJDK images is all done through Jenkins now and pushed to openjdk.linaro.org. So those tests were, I think, are now completed. I mean, they really are a subset, and some of the configurations there, they're probably only running one test. So if we go back to our dashboard, right, we can see the last duration was 1 minute 40 seconds. And perhaps if we look at one of the jobs in particular, if we look at, say, this one, we look at the console output. Okay. We can see basically we're using, we basically copy the image that we've previously built as part of the continuous integration. We unpack it, and then it starts running some of the tests. And as I said, you can see in this particular case, pass 1, not run 5,000. So just switch back. So I think that's all I had at this part. Michael, did you want to talk through these slides? Or? Okay.
So, yeah, so I was just going to cover a little bit about what it's been like to use OpenStack on ARMv8. And I think, to be honest, this has been more about me learning about OpenStack than anything that's actually ended up being ARM64 specific. Yeah, so it is possible on Trusty to install OpenStack both with DevStack, requires a couple of changes around package names, or using Juju, which is a canonical supported deployment method. It's not completely straightforward, but it's pretty easy. Yeah, like there's things like on the Mustang with the Trusty kernel, only one network interface is supported, and OpenStack really expects 2, so it's just a little bit of a problem. And I mean, for a production deployment, you definitely want to, because you want your instance, instant traffic to be on a separate path to your management traffic. And yeah, and Mustangs being development boards don't have out-of-band power management and stuff, so it's not a production-like environment, but it works. Yeah, and things like, so the sort of the Python web application-y sides of OpenStack all work fine, like Keystone and Horizon, the dashboard, work perfectly well, as you just saw. Nova, of course, is where the interesting stuff is, and it's where the higher up the stack you go, the less changes are required, I guess. So KVM obviously requires an enormous amount of work to get working on ARM systems. Libvirt requires some work, but not a huge amount. And Nova, I think we've got, well, just a slide to the one next to that. So there are some issues like there's no way of booting, well, at least with release software, there's no way of booting a VM with a bootloader. So you have to specify the kernel and init ID to OpenStack, and OpenStack boots the kernel directly, which means it's a bit more of a fiddle to administer, and it means you can't upgrade the kernel from within your VM. So, yeah, and well, it's running. I mean, it's running in the room over there. And again, we haven't, because of limited hardware and so on, we haven't done sort of realistic scale of deployment. So Swift works with the object storage part works with a single storage node, which is usually it has at least 3. Glance, the image service works fine. Networking, again, mostly because of time. In OpenStack, networking is provided by 2 services. There's the old-fashioned Nova network, which is what was originally produced, and that's all we've used, and it works well. There's also Neutron, which is the new hotness, apparently, which we haven't been able to test, just because of time. Yeah, so that was the slide I was hunting for earlier. It was 144 lines were changed in Nova to make it work on ARM64. Right, so this is, so the known issues. There's no migration support in KVM yet, which affects suspending, resuming virtual machines, and obviously migrating them between physical hosts. There's no volume hot plug. There's no. Linaro is working on this. Should be fixed. I don't know. Ask Christopher or someone fairly soon. There's no support in the model, in the emulated system for volume hot plugs. So this means you can't use network attached storage style things with VMs. So if this is what this is called, what Amazon calls EBS, elastic block storage, or in OpenStack it's Cinder. And again, this is being worked on and should be available hopefully by the end of the year. So those are things that just don't work. You just can't do them today. And then there's the stuff around the bootloader issues. Are more sort of, they don't prevent you from being able to use OpenStack, they just make it slightly more awkward. Yeah, and there's some related issues around identifying the block device that has the operating system on it as opposed to the ephemeral instance storage. Okay, I think that's all we had to say on those topics. Do we have questions? Oh, go on.
So this session is about Hadoop and OpenJDK on ARM servers. Although my name is on the slide again, really a lot of this comes from Ed Neville from Linaro, who unfortunately can't be with us this week. So let's have a quick look. So as a status update, I mean, the AArch64 port of OpenJDK, really based on the same code base as the x86 OpenJDK tree. And in fact, if you pull the AArch64 tree, you can build the x86 part, which I do occasionally. So there, as it says, there's really common code there between that and Oracle JDK. In terms of performance, within a few percent of the Oracle JDK right now. And the goal here for the AArch64 port is to track all the x86 optimizations that take place, and also additional features. And the key point here is there's no support for ARM v7 for 32-bit. So currently 3 releases are supported, JDK 7, so if you install, say, Ubuntu today or Fedora, you get JDK 7 with a JDK 8 hotspot. As I mentioned in the previous talk, there's also the JDK 8 tree, which is what internally I'm using a lot to do some dog fooding on the Jenkins master. That was released in April earlier this year, and it's starting to go into some of the distributions. And the ongoing, see if I can make that smaller. No. And then JDK 9, the tree is open right now in terms of development, and that's, as it says here, due for release next year. And the plan is to upstream the AArch64 port into that JDK 9 tree. So the two key technologies, I guess, in OpenJDK 8 for ARM is the server and the client compilers. The server C2 compiler is a heavyweight optimizing compiler. It can be slow to start up, but once it started optimizing, you get your money back if you like. For kind of interactive use, if you use the client compiler, the C1 compiler, it definitely starts up a lot quicker. And if you use it for something like even just Eclipse as an interactive environment, it's perhaps a little bit easier than, say, the C2 compiler. There is the tiered compilation, so code starts out first being optimized by C1, and then if there are some hotspots identified, then it's then passed on to C2. So you should get even better optimization happening there. There's the template interpreter, which I don't really understand, so I'm going to refrain from commenting too much on that. And then there's the pure C0 interpreter, and that basically is, you can run that anywhere. There is no architecture code specific to that. And that's also quite useful for a reference point. So in some cases, I've used it just to verify that there is a problem, say, in the OpenJDK tree, in terms of the hotspot, the C2 or C1 compilers. So right now we do basically a build of the OpenJDK tree on every commit into that tree, and we are building natively and testing natively on Applied Micro Mustang boards. We push those results to openjdk.linaro.org, and there's a broad spectrum in terms of JTREG as a regression test, and as it says here, there's like 18,000 tests, so it's pretty comprehensive. And then there are some other performance tests, the spec JBB, and if you go to the website there, you can actually see the numbers. JC stress is a kind of new test. It's a little bit experimental, and it validates the concurrency behavior of the JDK in the JDK itself, in the libraries, and potentially in the hardware as well. So as it says, and the test results are also posted daily to the AArch64 dev mailing list. The testing on the foundation model is abandoned or suspended, if you like. It takes too long to get some results back. So if a change is committed to the tree, we would really like to get the test completed within a 24-hour period, so that you can see that you haven't broken anything. So in terms of those tests that we run there, they consume quite a bit of CPU time in terms of running them against both the C1 and the C2 compilers. So here's a comparison against x86, and I think the broad takeaway here is that it's in the same ballpark. I think you'd have to go and look at the individual failures on both sides to see why that is. But I think the key point in some of these is that the error rate is very low, or comparable to what you see on x86. And my understanding of why there is some ongoing failures reported in x86 is perhaps those tests are not relevant anymore, and they haven't been commented out. So here we have a graph basically trying to highlight the difference between the client compiler and the server compiler. And in both cases, this is against a baseline taken on the 1st of April this year, which is what we call the FCS release of the OpenJDK tree. As you can see, if you use the server compiler, you get a massive performance win. So part of the testing and performance optimization is we use Hadoop. We build Hadoop occasionally. We don't do it that often. I'd probably do it every month, just pick up changes. We run a TerraSort with, I think it's 1 gigabyte TerraSort, but we only use a single node. So it's perhaps repeatable in terms of there's no other network traffic going on, and we can get similar numbers on a daily basis. There are not too many wild spikes. We're currently looking at multi-node testing, but no results to talk about right now. And then in terms of the optimization explicitly for Hadoop, as it says here, there's been basically a 24% improvement since the FCS in April. And I guess if you go back a slide, you can see that in this graph here. There are some optimizations which Ed has done for Hadoop directly. There is now a CRC implementation, a native one for AArch64. That's been pushed to the Hadoop mailing list, but my understanding is it's not been adopted yet upstream. So some updates since the last Connect, release of both JDK 8 and JDK 7. The images are available from the openjdk.linaro.org webpage, and in particular, we maintain, I think it's 10 right now, the last 10 builds that we did of OpenJDK 8. So if you wanted to try OpenJDK 8 on an ARM64 server, you can avoid the build, if you like, and actually use the images that we use for testing. The intent is to take the security updates, and I believe that has been ongoing since Connect. And I think the last point here is that, where is the OpenJDK 8 tree? And it is now at update 40, which I think in the previous Connect was update 20, but don't quote me. So further updates since the last Connect in terms of there's been quite a lot of optimizations being done. And I'm not going to read all these out, but in general, these are AArch64 optimizations. Prior to this, there is either a C or a Java implementation which is used if there is no native optimization. And I guess one of the ones which is kind of interesting down towards the bottom is the memory barriers, that optimization, and a nice headline figure there of 72% improvement, and then some smaller improvements on other benchmarks. JDK 9, the plan, from what I understand, is to merge the AArch64 port into JDK 9 at some point. There are changes going into both the JDK 8 and JDK 9 trees. And then a comment against other platforms apart from the Applied Micro Mustang. Those have been, we've been doing testing in-house. I think the statement is fully functional on both Juno and AMD. We have no external numbers pushed, but testing internally right now. And again, basically ongoing distro support with Ubuntu and Fedora and Debian. So I think, as we mentioned before, I mean, this looks like a duplicate slide perhaps, that the set of tests that we are running since the previous Connect has been expanded. So there we were mostly running the JTREG tests and the Hadoop, but the addition of the JC stress has been added, and the performance, the spec JBB performance tests. And again, those numbers are pushed for every change into the tree, and you can see those on openjdk.linaro.org. So the next steps for JDK 7, backport the optimizations, and we continue to track the security updates, but again, just highlight there is no support for 32-bit in JDK 7. For JDK 8, again, tracking the JDK updates. As you can see here, it says update 20, but I believe over the last couple of weeks that's now gone to update 40, and then continue the optimization work. And I think one area which is outstanding there is vectorization. And I think the comment here for JDK 9 is because both trees are currently being used, we're doing double commits into those trees. And then the final point here is that, continue with the release and testing on the member platforms. We're going to run the JCK internally, but for our own testing, really. And I think we're saying here that we're expecting the distros will run the JCK, and they will be concerned about the certification of those. That's it. Again, any questions?
In the first slide, you mentioned that it was close to OpenJDK's performance was close to what Oracle had. Was it close to behind or ahead?
I can't really answer that. I think this is a slide which has come from Ed, so I don't know the specifics on that one, so sorry for that. Any more?
Maybe I can comment. So the question was that you were mentioning that there's almost the same performance as the Oracle JDK. That specific bullet is related to the testing on on x86, comparing the official binary release versus the OpenJDK on x86. That gives the same performance numbers on x86 between OpenJDK 8 and the official JDK. So that's a confirmation of the statement that we believe that 95% of more of the code base is used between the open source project and the JDK.
Which end do you want?
Excuse me. Next page here. Has my machine just crashed? That would be hilarious.